week I've been showcasing a little bit of our color capabilities, which in a year from now we'll be able to show a lot more. But some more on when we brought in 3D printing to Legacy Effects. Like it was great having Scott on board because he came from the practical side and he knew what it was all about. And my commitment to Scott at the time was, I can reproduce what's on your screen. Because it's nothing like being an artist and wowing someone on your screen, and then when you physically get something in your hands, it's not being the same. I mean, let's face it, it's a flashy world in entertainment. If the director signs off on something on the screen, that's what he's going to want to see in his or her hands. So I made that promise to Scott that I would, everything that we get would complement his artwork. And to this day, what we have currently running right now, we run a Connex 3 in-house, we run a Connex 500 in-house. We also have a MakerBot Replicator 2 that we run in-house that's actually saved us on some versions of Captain America 2, believe it or not. We also run a Fortis 250 in-house for our FDM builds, so we could do enclosures and things like that, less detailed parts. And then we also run an Envision Tech Per Factory 3 for some really, really high resolution, smaller type jewelry type parts, smaller maquette things. So it's nice having this arsenal of machines in-house that I can complement these guys' work with and make the right selection for. Also, we have alliances set up with Solid Concepts that runs all of our large SLA builds, and then a company in Chicago called C Ideas that have the 3D Systems' newest iPro 8000s running some beta resins right now that aren't even on market yet. So we're getting large frame SLA builds that look like our object prints that are literally 3 foot wide prints.
In the 5 years I've been there, I've seen the technology go from like, okay, we're gonna print out this helmet, but we know we're gonna do the screws as, the model shop's gonna go in there and put the screws in, they're gonna put these details back in, they're gonna do all this stuff, which becomes a little problematic when you're sending files back to ILM or something, and they're like, well, wait, this screw's different than the digital model, so do we have to scan this and rebuild it? To nowadays, where pretty much what we print is pretty damn accurate. I mean, it's what you see is what you get.
We print out a 16 micron level for the most part, which is insane. I mean, that's smaller than a lot of our little strand of hair. I can print in rubber, I can print in clear, I can multi-material mix, and now I can overmold on top of color prints. I mean, what I can do for these guys to up their game in the concept world is just absolutely amazing. So when we built our shop, the first thing that Scott and I realized was we're throwing everything out the door that we had at Stan Winston, and we're going to totally change it all up. We're going to bring in in-house scanning. We have a couple scanners in-house. I fly around with a handheld scanner to get, if Scott's got to design a creature over, the actor that's cast, I'll show up in his or her hotel room, scan that data and get it back to Scott or Ian as fast as possible so they can start with their designs over it. So we built a virtual scan library in-house with a couple programmers that we have on call, and everyone that gets scanned, we just inject them with metadata. Weight, height, all of this stuff, and it's still, I get goosebumps to this day because I thought this would be something that I built that no one would use, and every time I go in Scott's office, he's still looking at the thing, pulling up stuff. And it's great because even if they haven't cast anyone yet, and Scott needs to start or Ian needs to start, he could say, okay, well, just give me an average height that you guys are looking for and things like that, and we can find someone in our library that matches who they're going to be getting, and these guys can just start.
Yeah, I can get started days before they've even scheduled a scanning for somebody. I can start on all the prep work, and that's another thing that we do. Almost all of our design now starting in 3D. We used to do 2D, but again, the promise that Jason made about we're going to do one-to-one, what you see is what you get, is the same thing that I wanted to deliver to directors and producers. What you see is what you get. So we've kind of backed off a lot on the 2D designing, and it was a pain for a long time, but once we got to a place where we could design in 3D quickly and do things on the fly, take it to them, then you end up at that point being able to deliver to the client what you see is what you get. He's delivering to us what you see is what you get, and and then we're building these huge libraries that we can start projects with just an inkling of what's going to happen. I think this is where they're going with this, and you just start designing knowing that the pipeline's in place to be able to just put the parts together and get it rolling.
It's pretty sick. Like, I always use the example, like if you ever come to Legacy, and Paul's been to Legacy, and it's just creating. And the art is just from these guys in their rooms, and then our bullpen designing shop. There's no hiccup. everything is just going. It's just like data is just moving and printers are constantly outputting. We run them 24 hours a day, 7 days a week. And we're just constantly creating for these projects.
Yeah,
and
I think we have
taking it
more
up.
hours on our printers than,
Oh, I'm
Yeah,
sure.
our original 260V to this day is still printing right now as we speak. I'm leaving here to go take it down when I'm done. Is over 14,000 print hours just on that machine alone, and we have 6 machines.
And when you think about the fact, like the commercials we get, the films have a little bit of time, even though that time is getting less and less every time. The commercials are, you'll get a call about a possible commercial. They'll want the design finished, and they'll want to be filming maybe a week from that day.
if that.
So doing stuff in 3D as opposed to like, hey, I did these sketches. Aren't these cool? Okay,
Now-
now I'm gonna
now
go
translate
sculpt. Yeah,
them.
now I'm gonna go sculpt it. Now we can go. Do you like this? Let me refine it. Do you like this? Great.
Was it
Let's send it out.
Year before last, we did 236 commercials in 1 year, and all the films that we do.
About 12 feature films a year we touch.
Yeah, we'll do about 12 features and over 200 commercials consistently.
Music
So,
videos, too.
Music videos, anything that, you know, just
Concerts.
anything that comes up, we do. But
Operas.
what's that?
Operas.
Opera. Did an opera.
We actually 3D printed for an opera. That's, I mean.
Costumes, you know,
that's
it was
pretty amazing.
It's once you know what. Like I said, the limitations, once the limitations start going away, you start finding places to use this technology. And it really bums me out when I see people that don't, they're like, well, it's not there yet. And it's like, no, and it's not going to get there until you embrace it and start using your own ideas and stop looking at, you know, I got a box that I could print, or I can print this Velociraptor head, because everybody's seen that, right? The little cube and the Velociraptor, and you go, nah, that's not what I do. And you walk away. And that's what most people who don't have any connection to the technology, they look at those things and they go, not what I want to do. And they're afraid to go, can it do this and can it do that? Well, can you do that? Can you make that happen? You know, that's
That's what really
it
comes
all
down
is.
to where we work,
Yeah.
is what can we find out to do with this stuff? We've done makeups, we've done complete creature heads, we've done complete robot suits, I mean, everything you can
I
imagine.
did my kid's Halloween costume. I bought a
Halloween
MakerBot and I have it in the garage, and I make their Halloween costumes. I vacuform off of the pieces that I do. I make maquettes. I do, you know, anything. It's
just constant.
And if you keep pushing those technologies, even though the ones that they call lower end technologies, if you're pushing those and making them do what they do best, it's not a low end technology anymore. It's something being used to
its advantage,
to its best advantage. Yeah.
Exactly. And a great example, what I had touched on earlier, was the promise that I made to these guys about staying one-to-one. Early on, we didn't know the tools around to make proper STL files, to make 3D printed ready files, and we were using ZBrush, and we were in talks with Paul early on. But so the hard part, like I said, was to make sure what you saw on that screen translated to the print. And without having programs around like Materialize Magics and things like that, we utilized XSI back in the day and heavily on ZBrush early on starting. We've always been in the beta programs with ZBrush. Very good relationship with our artists and all the guys at ZBrush. So this is what we were able to do years ago, as far as you can see the details in the 2 thumbnails on the left, and probably hard to see on the screen, but it's translated through the print. That's an object print. This is over for a movie from Life of Pi, about almost 3 years ago now. We were working on three and a half years ago, and it's lossless. From the techniques that these guys were able to come up with in software, especially using decimation in ZBrush, which I firmly believe outperforms any program out there for decimating.
I mean, the state of our models to the print would not be what they are without things like Decimation Master that in ZBrush. And if you guys are familiar with it, you know what I'm talking about. If you're not, it'll take something that's 6 million polys down to hundreds
It makes
of
the
thousands,
software worth
you
the
know?
purchase just for that feature. I mean, it's
I
that
mean,
powerful. You guys don't even use the sculpting tools.
Yeah.
There's
the
$12,000
losses.
programs out there that are supposed to be able to do that, and ZBrush kicks its ass in 2 seconds, and that's what
And it's
people are
fast.
relying on. It's super fast. Our artists are very comfortable using it. It's not science fiction. It just works.
And you can go back.
Yeah.
That
Exactly.
didn't work, go back.
And
do it
that's
again.
and that's huge for us because, like, you know, our assets get shared with visual effects companies like ILM and things like that. So our starting point of physical making is also getting handed over to an effects company for their starting point of rigging it up and taking it to where it needs to go.
On Cowboys and Aliens, we were designing the alien. We were figuring out how it was going to look and all that stuff, sending the files off to ILM so they could do walk cycles to make sure they liked the design in motion. Meanwhile, we're also printing out little heads to make sure that we like the way it looks from all angles. Then printing out maquettes with magnet snaps and stuff to show as we're changing it. So we'd have finished things with different changing pieces, all 3D printed. Meanwhile, using the ZBrush, sending it off to the animation
Yeah, sending
companies.
the same files.
So-
Every updated thing that we did got sent off
There was no
because it was a
question.
usable
Yeah.
file. It wasn't.
And how long ago was Cowboys and
Oh,
Aliens?
gosh, 5 years ago, 4 years ago?
And we worked
I've
on
been
that
trying to
a year
forget.
and a half before that. So it's like having this tool set and figuring out has just been great what it's been able to add to us in our whole pipeline. I firmly believe it's not the printers that we have in-house, it's the artist driving them. And the reason why everyone says, whoa, I've never seen prints look as good as it comes off of your guys' equipment. Well, that's because I do my maintenance on my machines. I do what I'm supposed to do on the machines to complement their work.
And we test
It's
this
as
stuff all the
simple as
time.
that.
We're pushing the boundaries all the time, doing like, okay, if I push my detail to a ridiculous level, when it prints, it might actually look better because suddenly it's just showing up a little bit nicer on this scale. So we're always doing tests with these printers to see just at what level does it break and what level does it work, and you adapt
And
that
what
into your pipeline.
scales work for what,
Exactly, and then-
detail wise.
You know, it's, you know, if you're printing like an Iron Man suit, something that has faceted type of geometry, those are pretty easy, boring type prints. But when you get into the organic world of creatures, something where every angle is different, really honing in on orientation on a printer and being really having your maintenance dialed and your machine locked in and printing at a 16 micron level. To the eye, you do not see grow lines with the techniques that we apply. And I think Scott and Ian are going to talk a little bit about what they apply to some of our files to just give it that last push so to the eye it looks even better than it is. So here's a great example. I mean, that's the caliber of our work. That stuff is right off of a 3D printer and finished and painted. So here's a great print that I always bring up, and it was given to me by Scott, and everyone thought this would be an impossible one to print, and we would never be able to get the quality that we would be able to
Back
get
in the
it.
back in the day.
This is
And
right
this
after.
is probably like
yeah.
5-6 years old now, this
No,
print.
it's 6, almost 6.5 years
Yeah,
old.
so this is it right here. I mean, doesn't get much better than that. That's a one-piece print. You can see all the detail in the braids, and what was pretty genius is, if anyone's familiar with this polyjet technology, is it comes in a wax-like support material that you have to water blast away. So the downside of that technology is that you could easily destroy your part in the cleaning process. So there was no way that we would be able to clean all these braids. So Scott came up with a really cool thing. At the bottom of all the braids, you see what looks like a spider. And Scott just made support structures in Z-spheres and ZBrush to basically attach every bottom of a braid. And that's how we clean this part to make it look so beautiful without breaking and holding up. And I believe you took this up on the retreat, right? Was this one of the ones
Yeah,
that went
that
up
was one of the ones,
after the Avatar movie to talk about?
My favorite story about this, by the way, which doesn't really have to do with 3D printing, does have a little bit to do with ZBrush, but the fact is, we were originally downloading Weta's Natiri file, so we'd have like the official one.
the final.
It was taking so long to download. Scott was able to sculpt this thing out, pose it, then we were able to print it by the time that we had finished downloading
Yeah,
the files.
I did that bust and a full scale bust that eventually became the sideshow bust, or the sideshow
The
30-inch
30-inch,
Natiri.
You can see
It
how
took 3 days to download all their material, and I sculpted it in. It was under 3 days. We had it printed out by the time
We were getting the
we had a
last of the
we had a
texture files.
18-inch print of her and that head for this conference we were going to. In the time that it took to download their files, we were just going to print their files. But again, we use the technology to our advantage.
Yeah.
We don't wait around for other people. So
Another great example of going from concept to even full size is when we worked on real steel. We had numerous design changes and iterations going on, so we're able to go, we did this maquette and I think it was just about a week.
Yep.
We went from a concept to breaking down to just some parts, some high-res 16 micron object parts. You can see all the details are in there. And then we're able to take it to a finished maquette within a week.
With lights and with the works.
Yeah, and then that got Sean Levy, the director, so jazzed that he gave us the approval to go full scale and make the real robots. So it's within a week to be able to go from concept to that is pretty amazing with the team that we have, and the technology and the software coming together is pretty amazing. Here's another example of some of Ian's work from a digital concept. I don't know if you want to talk about this one.
Yeah, I mean, this, to me, what was interesting on this one is if you go to the next slide, you'll see we have the actor scan under there. This was going to be one of the first makeups that we printed. The character ended up getting cut from the film, but it was a big test for us to see if we could actually, A, get the detail we wanted out of the machine on an organic level for makeups. Also to see that, like, where will the blend lines be, like on the lips, which are going to be more natural? Where are we going to have to just mix it with the clay to make this all work? We were able to get pretty accurate results just by using the scan of the actor, doing the sculpture on top of it. We printed out, if you go to the next slide, a small maquette version of this. And I don't have photos of the final makeup because I just never ended up getting finished, but it was fairly successful. They cut the character before we could finish it. I always thought it was an interesting test to see just how far we could take
It was pretty cool because like what you're looking at right here is a Vero black print at 16 micron, but the full scale head. At the time we were just limited to our small machine, which is just by a 10 inch by 10 inch by 8 inch platform, and it's a full scale alien head. We cut this thing up and it literally took me about a week to print. And then on top of that week of printing, they assembled it all back together, clayed in between the seam lines, and then actually clay pressed on top of it to even punch out more detail and run some silicone appliances. And it was phenomenal work, but character just wound up getting cut, so we have nothing really to show for it.
But there's no final payoff for it, but it was an interesting experiment, which has led into a lot of the stuff that we do now, where we've realized like where the detail didn't work on the print, where it was a little too soft in certain areas, we were able to punch it up on characters in the future.
And that's what's really cool. It's not just about the technology. We have the 25 years to 30 years of traditional experience behind it. Like, it jazzes me when Scott hands me off a 3D printed part for a makeup appliance that I see Richie and his team embedding into physical makeup appliances and working with it. The marriage of all the technologies and the artisan craft is pretty neat and what makes it come alive. So it's just some more of your stuff.
Yeah, this is just a little bit about the decimation master. This is something I did for a class of mine. If you look there, there's the concept, the model. Here's just some basic settings on what we do with decimation. From the final sculpt on the left all the way to the decimated one on the right, there's really, turning off the polygons, you don't see a difference in terms of the forms. You don't see a difference in terms of the detail. Yet it's less than half of the size of the thing. We could put this on a bed and grow it out without problem. The original one would have been, well, you can only have, what, 1 million something on the bed comfortably.
So the one thing that a lot of people don't realize, and what I try to make different for our guys, is everyone wants to sell you a 3D printer. Everyone wants to sell you a 3D printer. It's an easy bake oven. You're just going to output your files and you're going to be happy. But there are limitations with the technology, and one of those limitations being all 3D printers basically run off of a 32-bit system. So right there is the biggest wall that you have to challenge. They only address 4 gigs of RAM, these machines, so just getting files from these guys loaded into the machine and processed and sliced up and ready to go is time consuming. We don't run one part at a time. We fill up all of our beds with many files as possible. So now we have a limitation of how many physical pieces of geometry we can put on a bed and actually get through the process. So that's why decimation comes in hand, knowing the limitations of the machines.
Knowing how to slice it so that we actually can get as much on there with as limited time.
And also one of the biggest problems that other people have when they print is orientation on the bed. That is the number one thing when you are dealing with high detail pieces and something that just has to look great. If you laid it down flat and you printed it, and this is a face and the nose is facing out this way, you lay it down and you print it like that and you hand it to somebody, they're like, okay. But you print it straight up and you take advantage of every line of resolution. It's a completely different animal. And if you've got something organic that has a face or whatever, and you just simply cannot take maybe there's a mechanical piece coming out of the back of the head and it's got flat planes on it, and those flat planes are going to print and they're going to be striated, and there's nothing you can do about it. We've started to do stuff like add noise to something that should be 6-sided. You should be able to go, those are 6 sides, flat. They could be single polygons for all for all intent and purpose. They're not going to print properly if they're jammed into some organic piece and it's coming out at some weird angle. They're just not going to print. So we'll do things like adding noise to the surface of something,
Real slightly, real
just
a
slightly,
dusting.
not enough to distort the form, but enough to disrupt the decimation so that when it decimates the thing, it doesn't go flat plane, flat plane, flat plane, flat plane. It goes there's a lot of information here, so I'm going to try to break it all up. And what the machine does is there'll be points that are misaligned with its
What is the Z encoder
yeah,
or its X encoder?
yeah, and what it'll do is it'll go, well, I need to add a little love into that. I need to add a little, and what it does is it just noises up that surface enough to where you don't get these little blocky,
The wood
you know,
grain.
yeah, the wood grain blocky looking thing. So, I mean, it's just something to take into consideration when you see a print. Really take and look at it and think about, you know, what, if it doesn't look good, is it the fact that it was printed at an odd angle, or is it the fact that it's just maybe not a good print, you know, or maybe not the best, you know,
It's one thing
example.
to have a successful part being printed, but what we take pride in is really having the best looking part printed all
Yeah.
the time.
Yeah.
And that's one thing I think that sets our studio to the side, and people realize that when they see it, your prints look exceptionally well. It's because of the time that we put into just set up of files, make sure it comes through and just carries it all the way through.
Well, because, I mean, there's a lot of pride in handing something over and going, that's it, man, that's it, that's the way we wanted it. And having to hand it to somebody and say, clean this up, this little area right here, don't touch because it's kind of what we want, and then this area's a little weird, so prime that and sand it out a little bit. I mean, if you don't have to do that, well, you don't have to do it. That's, I mean.
Yeah, we don't want to waste the guys in the back's time with like fixing parts that we could have taken care of ourselves.
Yeah, I don't want to art direct them.
Yeah.
They do what they do, I do what I do, and I'm not going to try to tell them what to do, so.
What we want them to be doing is elevating from where we are as opposed to fixing from
Yeah,
where we
fix
ended
this
up.
for
Yeah.
me because you suck, you know?
Yeah. Well, I messed up, now you do this. So this was another little guy I did way long ago. One of the first things I ever 3D printed that Jason set up for me. What I thought was interesting about it is nowadays we use Magix at work, very expensive program, awesome for doing your slices, your booleans, and your keys and all that stuff. But Scott showed me something when I first started there where ZBrush by itself would make natural keys by polygrouping off these things and then splitting those off as your individual pieces before you decimate it.
Following an edge loop.
Yep.
An uneven edge loop around like an arm or something.
And then an XSI or Max, which it's weird, Maya wouldn't work this way because when it collapses, it would go off to wherever it wanted to, but in both XSI and 3D Studio Max, it would collapse dead center, which made a perfect key.
And they're
the
both,
teeth would
it would
actually
both
hold
be
it
the
right in
same, like if you split something on a edge loop and it was a curved edge loop that went around, if you split a piece off, it still retains this edge is the same edge on this one. So when XSI or Max would collapse it, they would collapse mirror images. So you get these weird striations that all went to a collapsed center.
you know, one
but when you
concave,
put them
one
together,
convex.
it was like
It's a natural key.
it's a natural key and it's
Now-
perfect.
It's perfect for us because we knew what the part was, and sometimes it's like, there it is, perfect. It's a little annoying when you're out on the shop floor, so now we use Magix because it literally is a beautiful
Yeah,
slice.
I mean, sometimes you go out there and an arm's on something like this.
Yeah.
That's probably not the way it goes,
Or they
guys.
start claying something, and you're like, no, if you just rotate it a little bit, it's gonna go, oh, okay, I didn't see that. So,
But this is, all
But this
part of
is-
the learning
yeah.
process.
and we still do this on the stuff that goes quickly, on things that we know we're just like, because
Yeah, we don't
Scott and I
send it
aren't
out.
big Magix guys. We mostly are doing the concept art. We're not doing a lot of the prep work these days. So when we're slicing things up, it's usually like, well, I know this is really fast and I can do this, and it's just going to be a one-off. So I'm just going to do it really fast, have this thing put out, and be finished.
And that speaks to the kind of, again, you use the tools for what you can make them do. And this thing that Ian did here is kind of an example, and I know people haven't seen MakerBot prints do what.
Jason was talking
What
to
we
me
were
for
doing
so
with
long
this.
about like, I want to print one of your things, and I was like, cool, we'll do it on the object back then. And he's like, no, I want to do it on the MakerBot. And I was like, that's cool, all right. I didn't expect much. I mean, I saw the parts that were coming from the MakerBot, and they were
When
really
he said
cool.
it, he looked at me, he turned around.
Like, I want it on the cool, expensive machine.
Everyone thinks I'm crazy, so.
So then, if you go to the next one, he prints this thing out and brings it in. First off, it's about the size of a softball. The detail on it is great. The color striations you see in there are actually more of a.
Those are color.
they're
That's
a color
not
issue.
line striation. That's not
That's
physical
just from the
striation.
actual material properties, and that it's a hollow point you're seeing through where it was bridging, but
To this day, we use this thing as an example of like, no, the MakerBot can do some pretty amazing detail if you prep it right.
I started tiddling around with, I met Bree 2 years ago at the London 3D print show, and he gave me a MakerBot replicator too before it hit market. And serial number 20, he's just like, just see what you can do with the thing. And I immediately took it home and I said, I'm gonna give it 10 days. Can I get it into the production pipeline at Legacy Effects in 10 days? If not, I'm just gonna push it to the side. About 2 days later, I was cranking out prints like this from just staying
If I'm
up
not
all night.
wrong, the resolution on this made you,
Oh yeah, 3 days later, I was like, can I get one of those?
and I'm buying one this year, so.
So what's really nice about it is everyone thought, oh, you're going to try to replace your printers at the job with MakerBot replicators now? And it's like, no. I mean, let's think about it. These guys are artists. These guys pretty much buy a new computer every year. You could pretty much hold that one computer purchase off and buy a replicator too, pretty much for the price of an iMac. Throw it next to you. Let me come over, hot rod it for you in software and a couple upgrades. that
You
I
heard
do.
him. He said he would.
Yep, his number will be next.
And literally, I'm gonna turnkey this system for you. And ever since then, I mean, Scott's coming in every day, wowing me, showing me the costumes he's doing for his kids, and all his projects at home. At this
Oh, my little
level.
crafts.
I mean, it's a pretty nice thing to be able to take a machine like this to do prototypes that cost, there's probably about $6 worth of material. if
Yeah,
that.
that was the thing that sold me when I was like, wait, how much did that cost if I had one at my house? $6? Oh.
Yeah.
And these are early on, where we've taken it even from
Yep.
here with certain materials that we've now honed in is unbelievable. I put them in the MakerBot guys' hands when I saw them in London, and they were just like, this is off of our machine, and it's off of your machine.
But that was the same thing that the Objet people said when we
Oh, yeah.
would do our
Yeah.
prints, and they go, "This is off of our machine," and it's all about how you approach it.
Yeah. And I think what's nice in this case is like the philosophy that we work in. I want these guys to create. These guys are not, they're technical guys.
And we're selfish and we want to
That
create,
gets
and
in
we
the
don't
way
care
of
about
their
them.
art, and I'm trying to be that bridge for them, and I get to play with the toys and do research and find new materials and technologies that just lets them just kick out stuff, and it just speaks for itself.